So, hello everyone. This is Dr. Bhushan Pradhan. I am going to tell you about the artificial intelligence today, and this is the very beginning class. So I will be telling you from the basic itself, so that we will be having a good understanding on that. So later on we will search the future slides, but today I will be telling you the basics of artificial intelligence. So how artificial intelligence actually work? That's what I am going to tell you. So artificially, it is intelligence. That means we will be given one source node or initial state. And in this example, in this graph, this is a graph, it is called as graph. So in this graph, A is my source node or initial state. So I need, suppose take for practical example, you are traveling from one source to a given location or destination. So in between, there are so many intermediate stoppages or stops it will be coming. So it is up to you how efficiently or how optimized way you are traveling from source node or initial state to the given goal node or the final state. Suppose my final state is E here. Suppose my final state is E. So how I am traveling from A to E, this is how we are going to see. Okay, so in this case we'll see how what is the searching strategies will be in order to search it. So as we saw here, artificial intelligence is nothing but searching from goal node to the source node. So I am traveling from A to the E here. So in order to travel, in order to find in order to go from source to node, I may follow different strategies. Different strategies that may include breadth first search, depth first search, or finally iterative deepening search. So today we are going to see best breadth first search and depth first search. What are they? And in the next class, we will be looking at iterative deepening search. So in that cases, suppose in here you will see that in breadth first search, it is saying that all the nodes are expanded at a given depth before any node at the next level are expanded. For example, this is depth 1. Okay, so this is depth 1. Suppose this is depth 2, this is depth 3. So suppose I am in depth 2, so all the nodes will be expanded or searched before going to depth 3. That means in order to suppose my goal node is G here, the worst case scenario here, it will be G. Suppose my goal node is G, then how, in which way I will be traveling? First I will travel from A, then I will travel then I will come to B. Okay, then C, then D, E, F, and G. Right. So in this way, I need to travel. Right. So in this way, I need to travel here. So you can see here A. It is A, B, C, D, E, F, and finally G. Here G is not written here. So what are the advantages and disadvantages? The advantages and disadvantages are, these are the one. Whether it is complete or not, what is the time complexity, what is the space complexity, and whether it is an optimal strategy or not. Depending upon these four different criteria, we can say that whether this is an efficient searching strategy or not. For example, whether it is a complete or not. What do you mean by complete here? Completeness in the sense that if I started searching, if in all searching time, it is able to search the given goal node, then it is a complete searching strategy. So here we can say that it is traveling, it is touching to each node always. So definitely it is a complete searching strategy. So because it is a complete searching strategy, this is the biggest advantage of breadth first search. But the drawbacks are it is requiring or it is consuming more number of time and more number of space. The time complexity is on the order of b to the power d, and space complexity is on the order of p to the power d again. So here we need to understand what is b and what is d and what is m also. So let us again go back to our graph, which is given here. So b is nothing but the branching factor. Here branching factor is maximum number of branches for each given node. Suppose A has the given node. What is the maximum number of branches? 2. Similarly, for B, it is 2. C, it is F, it is F and G, it is 2. So overall in the graph, the maximum number of branches is confined to 2 only. So in that cases, B equals to 2. Similarly, what is D? D is the depth at which the goal node is present. Suppose my goal node is present at C, then depth is 2 here. Suppose my goal node is F, then the depth is 3 here. So it is the depth at which the goal node is present. What is M? M is the maximum depth of the graph. So here, what is the maximum depth of the graph? It is 3. So always you will see that M is greater than D. So considering these factors, what is my time complexity? Time complexity is maximum number of is on the order of b to the power d. Okay, time complexity is on the order of b to the power d, whereas space complexity is on the order of b to the power d. So here b to the power d is the total number of nodes it is saying. So here we can say that the space complexity is very high. So we are not generally consider this best first search. In order to circumvent this difficulty, we go for the next searching strategy, that is depth first search. So what is a depth first search? Depth first search is the one where it follows the rule that it expands the deepest node in the current fringe of the search tree. It expands the deepest node in the current fringe of the search tree. So in this depth first search, what will happen? Here it expands the deepest node. For example, instead of going breadth wise, it now travel depth wise. Okay, suppose first it will travel, try to complete this branch. Okay, so in this branch, so it first go to the deepest node. So what is the deepest node here? The deepest node is E here. So after searching E, the next deepest node is D. So first it will search E, D, then the next deepest node is D, then this branch is completed. Similarly, what is the next branch? Next branch is G, F, C. So these branches are completed and finally it is A. Okay, so finally it is A. So let us see what are the different nodes it is traveling. So D, E, B, F, G, C, A. So here it is D, E, B, F, G, C, and A. So this is how it is traveling. So what are the advantages and disadvantages? So in order to consider the advantages and disadvantages, let us consider these 4 factors. That is time complexity, space complexity, completeness, and optimal. So whether it is not a complete strategy. Why it is not a complete strategy? The reason is that suppose this one of the node is deepest to infinite length. So in that cases, it will be busy on searching one direction only. It will never look at the other direction. Suppose our goal node is C, so it will never come to the C node, right? So this is how these are the drawback here, right? So it is not a complete strategy. So it is not a complete strategy. So here in these cases, what are the other things that we need to consider? Time complexity and space complexity. The time complexity, we will see that it is requiring on the order of b to the power m, where m is greater than d. So it is requiring more time. It is requiring more time as compared to the breadth first search. Whereas the space complexity is, on the order of bm. So if we will compare the space complexity, this is a exponential increasing, this is a linearly increase in number of nodes. So definitely this is requiring very less space as compared to the breadth first search. And it is definitely not an optimal strategy as compared to the breadth first search. So here we have considered today different searching strategies. So here I can say that we considered breadth first search and depth first search, and we saw the individual merits and demerits in them. So next class we will be discussing in more detail about the iterative depending search, which is a combination of breadth first search and depth first search. And we will see that Definitely, the iterative depending search is an optimal strategy as compared to as opposed to this breadth first search and depth first search. So till then, we'll see in the next class. So then for today it is I'm stopping it here, and we'll see in the next class. Okay, thank you.